As promised, we are back here at ISO Math and ready to graph the cosine. So we have the function. This time our function is f of x equals cosine x. And what this function is going to do is measure the horizontal distance from the y-axis. Let me just do it here. Let me make a table again. X and cosine of x. So when x is 0, we're there. And the horizontal distance is that distance. The horizontal distance from the, or let's just say the distance from the y-axis. And so cosine of x equals 1. Cosine of 0 equals 1. Okay? What about when we're at pi over 4? We're right there, so pi over 4. What are we going to get? The horizontal distance there from the y-axis is going to be, we know the cosine, the value is root 2 over 2 at pi over 4. So the cosine of pi over 4 is root 2 over 2. And the next one, we go here at pi over 2, and the horizontal distance, so the horizontal distance from the y axis is 0 because it's actually on the y-axis. Let's go to 3 pi over 4, and what are we going to get? The horizontal distance is the same as it was in this one, except it's the negative value, negative root 2 over 2. Okay, now let's go to pi, so a radian measure of pi, and let's look at the horizontal distance is of course going to be negative 1 there. Well, I guess I shouldn't say the distance is negative 1. At the x coordinate is negative 1. You can't really say distance is negative. Distance doesn't have a sign. Distance is always positive. So, but keeping in this perspective here. So let's go to now. What's that going to be? 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5 pi over 4. Again, we look at the horizontal, the x coordinate. Think of it as the horizontal distance, but it's in the negative direction there, so it's a negative root 2 over 2. At here, again, we are on the y-axis, so at 3 pi over 2, we have that the distance from the y-axis is, of course, 0. This is x cosine x at, when x is, what's that going to be? 1, 2, 3, 4, 5, 6, 7 pi over 4 radians. 7 pi over 4. We have that our horizontal distance here is root 2 over 2. There's no reason I made that one red except that I forgot to switch. So now then we're back to 2 pi, back to where we started. 2 pi, and we are going to get that its horizontal distance is that distance there, which is of course 1. And then note this thing is just going to start repeating. So the graph that we get from this, if we continued on, it would just start repeating itself. So let's sketch this graph. So let's sketch the graph. Of f of x equals cosine x. Okay? And we're sketching on this domain here, and let's say that this is going to be my -1, this is going to be my +1. And again, as in the last video, let's make our increments of pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. And that should have been pi over 4 there. Okay, so here's my x, here's my y, and so at pi over 4, let's say at 0 radians, where are we at? Oops. So at 0 radians, our cosine of 0 is 1. So we're there. Okay? At pi over 4 radians, we're at √2/2, and from our last video, we saw that that was about 0.7. If we want to sketch a graph, it's easier to think of it as 0.7 rather than negative √2/2. So 0.7 is going to be somewhere around in there. After pi over 4, what do we go to? Pi over 2, and we get that we're at 0 again. Or not again, this time, it's the first time we're at 0. And then, so 1, 2, 3 pi over 4. At 3 pi over 4, well, I'm having trouble getting it to click up, but at 3 pi over 4, I know we're at the √2/2 again, the negative √2/2. At pi, let's see, edit, delete page, here, okay, there we go. At pi, we're at -1. If you look back on the table, I'm having trouble having it pop back up, but anyway, so then at 1, 2, 3, 4 pi over 4, at 5 pi over 4, we are again at negative √2/2, which is about -0.7. At 1, 2, 3, 4, 5, oops, 1, 2, 3, 4, 5, 6 pi over 4, we are at 0 again. So 6 pi over 4 is what? 3 pi over 2. So that is, yes, at 7 pi over 4, we are at the √2/2 again. So that's about 0.7. And at 2 pi, we're back at 1. And so we get this beautiful curve here, if I can sketch it beautifully. I always do little sketches, because if I try to draw through it all at once, it's always ugly. I always find that it looks better if I sketch it out like this. So that is f of x equals cosine x. Okay? Know how to graph this graph. Let me see, I'm looking on time, 8:44. Let me say one thing that I really didn't say about the sine. Let's talk about what's the domain of f when f is the cosine. Well, I can look at any radian measure I want, because the radian measure is just going to tell me how far to go around the unit circle. So I can go in any direction I want and stop and see what the x coordinate is. So the domain of f is going to be all real numbers. So for the cosine and the sine, the domain is going to be all real numbers. For the range of f, that's going to be where do my outputs go. So here, for the cosine, they go between -1 and 1. There, everything is, so all of my x values are between -1 and 1. So my range is -1 and 1. And if we look at, let's say g of x, equals sine x, again, so the domain of g, I can go around the unit circle all I want and measure, and then stop and evaluate what its y coordinate is. That's all sine x does. and so my domain is all reals, and the range of G for the sine is going to be from -1 to 1. Again, the same thing, so all of my y coordinates are trapped between -1 and 1, and can include -1 and 1 as well. Okay, so I hope that helps you out with the graph. I will have one more video using some cool technology of describing the graph of the sine x and cosine x. So I'll see you on the next video.